Out of all the things we can speculate about space, the concept of extraterrestrial life has to be one of the most intriguing. Although seen mostly in the form of science fiction depiction, alien life has long been viewed as a real possibility. How do we have any idea how many, if any, intelligent extraterrestrial beings are really out there? Are we alone in the universe? Time to find out. Let's take a look at an example that I have set up. Let's say there are around 100 billion stars currently in the Milky Way. Now let's say that 10% of all those stars have one planet that is in the Goldilocks Zone. The Goldilocks Zone is a term used by astronomers to describe the area of a solar system that would potentially be suitable to hold life based on its distance from the Sun. A planet in the Goldilocks Zone would be like Earth, not scorching hot like Mercury or Venus, but not freezing cold like Neptune. If we're looking at exactly one planet per each of these systems, we've narrowed it down to 10 billion planets in the Goldilocks Zone in the Milky Way. Now moving on, let's say that 5% of all these planets are actually suitable to hold life. Planets in the Goldilocks Zone are said to be capable of holding life, but let's say that only 5% of these planets actually have some form of life on them. This life could be bacterial or even sentient. If we say that 5% of the 10 billion planets have some form of life on them, that means we have 500 million planets in our galaxy that contain intelligent or non-intelligent life. Finally, let's say that 1% of these planets that contain life actually contain intelligent life. Intelligent life, although kind of an obscure term, would mean that this planet holds life that could build civilizations, create social structures, and perform general intelligent cognition. If you were to narrow it down in all these different ways, we would have approximately 5 million intelligent species residing in the Milky Way alongside us. Now remember that these numbers, besides the size of the Milky Way, were entirely made up, and the real ratios are probably wildly different from just the random ratios that I threw out. In addition, there are hundreds, if not thousands of other factors to consider when actually calculating these ratios. Again, this was simply to show this concept. This line of thinking is exactly what the Drake equation represents. Essentially, we are taking a number of potential stars or planets and using a series of ratios to determine how many planets hold intelligent alien life. It might sound complex, but the equation that represents this, otherwise known as the Drake equation, is very simple. In the Drake equation, you have a series of variables that all multiply together to equal n, or essentially the number of potential civilizations that are advanced enough that we might be able to communicate with. The variables are as follows. R sub asterisk is the rate of development of stars that could house a planet which could host intelligent life, measured in number per year. F sub p is the fraction of those stars that contain planets within their solar system. N sub e is the number of planets per each solar system that have an environment suitable for life. F sub L is the fraction of suitable planets where life actually exists. F sub I is the fraction of planets containing life on which intelligent life actually emerges. F sub C is the fraction of those intelligent species that are advanced enough to host potential communication methods with us. This helps us to understand how many civilizations we would be able to detect. We would have a hard time detecting any intelligent civilization that is relatively primitive when compared to our technology. L is the amount of time in years that these civilizations produce detectable signs of their existence. The Drake equation helps to give us a quantitative way that we can approach the question of alien life, and it is a far more logical approach than pure qualitative speculation. Let's take a look at what the original estimates for each of these values were. R sub asterisk equals 1. One star is produced per year in our galaxy that is capable of hosting intelligent life. F sub p is between 0.2 and 0.5, meaning between 20 and 50% of the suitable stars host planets within their solar system. N sub e is between 1 to 5. For each star that has planets, around 1 to 5 planets will exist within the solar system that are capable of sustaining life. F sub L equals 1. There is a 100% chance that each of these potentially habitable planets will have at least some form of life. F sub I equals 1. There is a 100% chance that out of the possibly millions of species on each planet, at least one will emerge as intelligent. F sub C is between 0.1 and 0.2. 10 to 20% of these intelligent life forms will be able to communicate via some sort of electromagnetic wave, therefore being visible on our radar. And L is between 1,000 and 100 million. These civilizations that can communicate will produce detectable signs of their existence for between 1,000 and 100 million years. After running all these variables through the equation, it turns out we would have 50 million civilizations in the Milky Way that are advanced enough to communicate somehow via electromagnetic waves. These numbers were proposed in 1961 by Dr. Frank Drake. the man who the Drake equation is named after. He was an astrophysicist that is known for founding SETI, which you'll discuss shortly. These initial values have received a fair amount of criticism, and there are a million different ways that you could debate these values. But regardless of their exact precision, we would still be left with a fairly high number even if we were to lower these ratios. Even if we have very small ratios, the sheer size of the Milky Way almost guarantees mathematically that there has to be some sort of intelligent life coexisting with us. Now this leads us right into the Fermi Paradox. If the odds of intelligent life emerging in our galaxy are so high, how come we haven't run into alien life yet? Theoretically, given the potential odds of alien life that should be detectable, we surely should have detected at least one by now. The issue is, we haven't. So, put into highly intelligent words, where are the aliens? The Search for Extraterrestrial Intelligence Institute, otherwise known as SETI, has the following quote on their website regarding the Milky Way. Within 10 million years, every star system could be brought under the wing of an empire. 10 million years may sound long, but in fact it's quite short compared with the age of the galaxy, which is roughly 10,000 million years. Colonization of the Milky Way should be a quick exercise. SETI is referring to a civilization that has modest rocket technology and some form of imperial ambition. The reason it's labeled as modest is because even going at a small fraction of the speed of light, it would take only a couple million years to successfully traverse or colonize the galaxy, a time period far, far shorter than the total age of the Milky Way. We know the universe is billions of years old, so a couple million years might sound like a lot to us, but it is realistically a tiny fraction of the age of the universe. Isn't it easy to assume by knowing that information that if the odds of the Drake equation tell us there have to be countless intelligent civilizations in the Milky Way, that one likely could have colonized it by now? Using the initial yet very controversial 50 million number we got earlier, we are saying that there could be approximately 50 million intelligent species sharing the Milky Way with us. If all of these 50 million civilizations are capable of producing electromagnetic waves, it is probably fair to assume that most of them have modest rocket technology or are very close to it. So how come we as humans have had zero contact with any intelligent alien species? If we are saying that the universe is somewhere in the realm of 13 billion years old, and it would take approximately 10 million years for a moderately intelligent species to colonize the Milky Way, we can reasonably say that it would take less than 1% of time regarding the age of the universe to successfully colonize the entire Milky Way galaxy. If we're saying 50 million moderately intelligent species exist or have existed throughout the history of the Milky Way, throughout the lifetime of the universe, why hasn't a single one been able to colonize the Milky Way, at least as far as we know? Considering that we're talking about less than 1% of time that the universe has been in existence, it should theoretically have been very likely that at least one civilization could have done so by now. What could be the reasons for this? Perhaps there was a galactic empire a few billion years ago that fell due to internal conflict. Maybe there have been millions of civilizations that existed at a different point in time that all collapsed long before we showed up. In a future video, I'd like to explore the possible reasons behind why we haven't come in contact with intelligent life. Here's a short little summary of what we've talked about. If we were to take the total number of stars in the Milky Way and multiply that by a series of ratios that help us to determine how much intelligent alien life exists with us in our galaxy, we would have the Drake equation. As you've seen with the Drake equation, the odds that we coexist with many other intelligent species are very high. The Fermi Paradox is the apparent discrepancy between the math that shows there is very high probability we are not alone, and our actual observations that show we have yet to have contact with a single intelligent species. What are we missing? If you liked the video, please consider subscribing and hitting the like button. It helps me out a lot and I'd really appreciate it. Let me know in the comments if there's any future content you would like me to cover. Until then, I'll see you next time.